All right, so we're going to talk about factoring polynomials. But before I get into factoring polynomials, I want to talk about multiplying the polynomials. Because factoring the polynomials is really just doing this multiplication of polynomials in reverse. All right, so first we're going to be doing our distributive property of x times x. So we have x squared, and then x times the 5, so a 5x. And then the x, or 7 times the x, so plus a 7x. And then plus 35. We've now multiplied all the terms in the first quantity and all the terms in the second. I can now get those into x squared plus 12x plus 35. All right, now, well, let's go ahead and continue before I break that down a little bit further. With this next one, we've got an x times an x, so x squared. We're going to have a negative 1x and a negative 8x. So when those are combined, we'll have negative 9x. And then a negative 1 plus, or negative 1 times negative 8 will give us a plus 8. All right, and in number 3, we're going to have x squared. We'll have a negative 4x and a plus a 1x, so a negative 3x. And 1 times negative 4, negative 4. Now what I want to talk about is how some of the things we can see from what we just did, what they tell us about the original factored expression. All right, so first and foremost is this sign right here. Now, in both of the first situations, that's a plus. And in the second one, it's a minus. That is coming from both of the signs being the same. So in the first one, both were pluses. If I multiply two positives, I get a positive. The next one, they're both negatives. If I multiply two negatives, I will get a negative. So if that sign right there is a positive, if it's a plus, then we know that both of the signs, both of the operations in the first one are going to have to be the same. Now, if both of them are going to be the same, we're going to look to this next, because that is going to tell us whether or not we were adding or whether or not we were subtracting. Okay, so because here in blue, in the first one we were adding, we noticed we had a plus 12x. Well, we added two positive numbers together. In the next one, we added two negative numbers together. And surprise, surprise, we were subtracting in both of those. Now, we've been ignoring this last one. What it means is that when both of them, when we've got a subtract, it means both are going to be different. We have a minus and we've got a plus. The first one also tells me something important. It tells me the sign on the bigger number. So in this case, we got a negative. Our bigger number was a 4. And that's why. So our bigger number was the 4. It was also being subtracted, and that's why we got that negative right there. So seeing these things tells us a little bit about how we can look at an expression and then take it back to that factored form. Now, I'm not going to do all of these. Let's just go ahead and focus on 5. I do want us to also see how having a coefficient on one of our variables is going to affect this. And that can get even more complex in having a coefficient on both. Now, as I multiply this, I'm going to have 3x times x is just our 3x squared. Our 3x times the negative 8 would be a negative 24x. Our negative 1 times by the x is going to be a negative 1x. So negative 24 and a negative 1x, negative 25x. And then negative 1 times the negative 8 is going to be positive 8. So once again, we see a few things that are familiar. We see that this was a plus, and we had the same sign. We see that this was a minus, which indicated to us that because both were the same sign, those were also minuses. Okay, now the 25 is far bigger than just adding up our two constant numbers. This time it was we multiplied one of those constant numbers by our leading coefficient and then added them together. Now that will make some of the following problems a little bit more complex once we get into them. All right, but let's go ahead and just get started. First, I'm going to be looking at that sign right here. That sign is going to tell me something about these. Now, in the first one, it is a minus. That means I'm going to have, in both my situations, one would be a plus and one would be a minus. I'm going to multiply a positive and a negative together. Next, we've got this one. It says positive, which means that my bigger number is going to be in the plus end. So now I just need to think of the factors of 10. Well, factors of 10 are 1 and 10, and 2 and 5. All right, now those are going to need to combine through subtraction. We're going to combine them using subtraction to create a 3. All right, well, 5 minus 2 is 3. And we already learned that because it came out positive, the bigger number needs to go with the plus. So 5 was the bigger, 2 was the smaller, x and x, and I factored it. Okay, so now with this next one, we have got a positive. Both are going to be the same. We also notice that right here, that's also a positive, meaning that both are going to be adding. So I can set this up right now. Plus, plus, x, x. Now factoring on the factors of 30, so 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now, from that list, I want to figure out what, using addition, is going to combine to make an 11. All right, well, 5 plus 6 is the one that will combine. Both of these are add, and so it's really not important where I put the 5 or where I put the 6. But the factored form, x plus 5 times x plus 6. Now, this one is also kind of tricky because I don't have my x to the power of 1 term. Now, in my other video on factoring, there is a method called the difference of squares that could be used here. I'm not going to use that right now. I'm just going to use the same method we've been doing, and I'm going to break it up this way. So x squared, I would also have a 0x, and then minus a 36. All right, so now that I've got that, I need to figure out what are the things that multiply together to give me 36. So 1 and 36, 2 and 18, 3 and 12. And we could go on, and 6 and 6. Now, I know that because we got this minus right here, they need to combine to make 0. All right, well, 6 and 6. So 6 minus 6 is going to give me 0. So now that I know that, and I know it was minus, so they're different, so I'm going to have 1 plus, 1 is minus, got my x, and then 6 and 6. So I'm going to have a 6x minus 6x gives me 0, and a 6 times negative 6 gives me negative 36. All right, so now here's where we're getting a bit more complex. We've got a leading coefficient in each of these. We've got a number that's with that x squared. It can make it more tricky, but so long as you remember where these numbers are coming from and how they came from that factorized form, we can still try to work it backwards. All right, so first, we add a minus here, which means different signs. So plus, minus. Got an x, got an x. One of those is going to have a coefficient in front of it. Okay. Next, I'm going to do my factors of 14. 1 and 14, 2 and 7. Sweet. Nice and easy. Now, this 5 was multiplied by one of those, and then once again, we subtracted them to get a minus 3x. All right, so we have to multiply one of those numbers by 5 and then subtract the other one to get a 3. Now, I'm just going to start with experimenting. If I do 5 times 1, that'll be a 5 minus a 14, and I'm going to get a 9. That didn't work. All right, 5 times 2 is going to be 10 minus 7. That's 3. Sweet. So I know I multiply the 5 and the 2. So 5 and 2 are going to have to be in opposite parentheses. I'm going to multiply 5 and 2 and then subtract the 7. Our 3 is a negative, meaning that the bigger number has to be a negative. Now, I know I'm writing the 2, which looks like the smaller number, but it was really a 5 times the 2 was the 10. In this case, a negative 10. And that was the bigger, and so 7 was the smaller. So we'll have a negative 10 minus a 7x to give us that negative 3x. All right, now we got a minus, so instantly I already know in my 2 parentheses, 1 is plus, 1 is minus. This time we had a positive 3x, so my bigger number has to be a positive. I'm going to start getting my factors of 27. So 1 and 27, 3 and 9, and that's about it. Now, I do also need to remember that that 2 was multiplied to one of those and then subtracted to get a 3. So 2 times 1, it's going to be 2 minus 27, 25. Yeah, that doesn't work. 2 times the 27, 54 minus 1. No, that's way off. 2 times a 3 is a 6, and 9 minus a 6, that gives me a 3. So I'm doing the 2 times the 3, and that's a 6. Remember, this was a positive 3, so our bigger number has to be the plus number. So between the 6 and the 9 is going to be the positive. Okay, which means that my 3 over here, which needs to turn into a 6, is going to be the negative. My 3 and the 2 go on opposite sides. All right, and just think about how that's going to work. 2x times x gives me 2x squared. 2x times the negative 3, negative 6x, plus a 9x will give us the 3x, and then 9 times negative 3, negative 27. Now, there is one other way of going about this. You're largely going to be doing the same work as far as finding factoring, but that is factoring with grouping. I do have another video. If you are interested in trying factoring with grouping, you can also do factoring with grouping here. It's another method. Some people prefer it, some people don't. The thing to keep in mind is if you do want to go try to use factoring with grouping, you are going to be trying to find a lot more factors than we are here. So here with 8, I'm really only doing 1 and 8, 2 and 4. And that's pretty much it. If I was doing this using factoring by grouping, I'm going to be dealing with doing a lot more factors that way. So there's some give and take, but if you're confused by this, try and see if that method doesn't look a lot more clear to you. All right, so to begin with, plus sign, sweet, both of them are going to be the same. Next, I see that that one was a minus sign. It means both of them are going to be subtract. So we got both of these being subtract. We've already found our factors of 8. We know we're going to multiply one of those factors by a 3. And then we're going to add them to get a 14. All right, so 3 times 1 give me a 3 plus an 8 would only give me 11. 3 times 2 is 6 plus a 4 is only 10. 3 times 4 is 12, and then plus the 2 would give us 14. All right, so that's our winning combo, is having a 3 times the 2 and then, or 3 times the 4 to give us a 12 and then plus the 2. So got my 3x and the 4 on the opposite side, so we'll have 3x times 4. And there's my 2. One extra thing to bear in mind, in these examples I'm focusing in on where the leading coefficient is prime. That's not always the case. In this situation where it is prime, I do like using this method of a quick guess and check. I'm dealing with a lot less factors. If it's a composite number, a number with its own factors, we could be dealing with possible polynomials in which both of our x's have a factor. And so this would be an example that when we take it all out, our leading coefficient is going to be a 6x squared, a composite number. So just be aware of that as we're going through this. With composite numbers as your leading coefficient, I actually might suggest doing the factoring by grouping, though you can still do it here. It's just a more complex process of thinking, all right, it could either be I multiply by a 3, or I'm multiplying by a 6, or I'm multiplying by a 2 and another number by a 3. You just have to put more thought into it. Okay, so now we're going to factor these ones. It's a plus. Both need to be the same. That one's a plus, so they're both going to be add. Factors of 6 are going to be 2 and 3, 1 and 6. I am going to multiply one of them by 5, because 5 is prime, so it's the only possibility we're looking at right now. Multiply one of them by 5, and then we're going to add them to get the 17. So 5 times 2 is 10, plus 3 is only 13. 5 times 3 is 15, plus the 2 would equal 17. So 5 and 3 on opposite sides, so they get multiplied, and then 2 over here. And we found it. Okay, so now we've got subtract here. Both are going to be different. We'll have one is plus, one is minus. The next thing to notice, that's a negative, so my bigger number is going to have to be inside of that minus. Factors of 22, 1 and 22, 2 and 11. Okay, and that's about it. That's our prime factorization right there. So we're now going to be multiplying one of those by a 2, and then, just like it has right there, subtracting to get 7. All right, so 2 times 1 is 2, minus 22, we're going to get a negative 22. So that doesn't work. 2 times 2 is 4, and 11 minus 4 will be 7. So that's our winning combination. We're going to have 2 times 2 is 4, and the 11, remember the bigger number is going to have to be negative so that the 7 comes out as negative. So I'm going to make the 11 a negative, which means that we're going to have the 2 over on this side. We did want to do the 2 times the 2 to get the 4, so my 2 2's are on opposite sides there. And we got quantity of x plus 2 times the quantity of 2x minus 11. All right, so now once again, minus right here means both are going to be different. So 1 is plus, 1 is minus. Do you see that it's going to get a positive 25? So my bigger number is going to have to go here in the plus area. I need my factors of 12. So 1 and 12, 2 and 6, 3 and 4. I also know that I'm going to be multiplying one of them by 7. 7 is prime, so it's really the only number that we're going to be using here. It's not composite. So 7 times, and I need to get a 25. They're going to subtract, so 7 times 1 is 7 minus 12. Nah, it didn't really work. 7 times 12, I'm going to get a big number and minus a 1. No, that doesn't work. 7 times 2 is 14 minus the 6. No, only gives me 8. 7 times 6 is 42 minus 2 is 40, so that didn't work. 7 times 3 is 21 minus 4. No. 7 times 4 is 8. 28 minus 3 will be 25. All right, so we know we want 7 times 4 gives us a 28. So we're going to have 7x times by the 4 over there, x, and there's our 3, and that is our final factorization.